video is about guardrails. Still in the production layer. Every AI system you ship to real users needs safety rails. Not because AI is inherently dangerous, but because users will always try things you did not anticipate. This video shows you how to build input and output validation that catches problems before they reach your users or your language model. So, what is it? Guardrails are validation layers that sit before and after the language model call. Input guardrails inspect the user's prompt before it reaches the AI. They block prompts that contain prompt injection attempts, personally identifiable information, off-topic requests, or jailbreak attempts. If the input fails, the LLM never sees it. Output guardrails inspect the AI's response before it reaches the user. They validate that the response has the expected format, check for toxic or harmful content, and verify that no confidential information leaked into the response. If the output fails, the system retries once, and if the retry also fails, it returns a predefined safe fallback message. The airport security analogy captures this exactly. Before boarding your flight, security scans for dangerous items. After landing at your destination, customs checks what you are bringing in. Two separate checkpoints catching two different categories of problems. Skipping either one creates a gap. Next, workflow. The workflow has 5 steps. Step 1, raw user input arrives. Step 2, the input guardrail runs checks on the prompt. If any check fails, the request is blocked immediately. A safe error message is returned to the user. The language model never sees the blocked request. Everything is logged. Step 3, if the input passes all checks, the LLM call runs normally. Step 4, the output guardrail runs checks on the AI's response before it is returned to the user. If the output fails, the system either retries with a corrected prompt or returns a safe predefined fallback message. Step 5, the validated response reaches the user. Look at the 2 boxes at the bottom of this slide. The red box shows what happens when the input guardrail fires, block immediately, and log. The LLM never sees the request. The orange box shows what happens when the output guardrail fires, retry once, then fallback, log both failures. The key difference in strategy is intentional. Input failures are blocked outright because a harmful or injected prompt should never reach the model under any circumstances. Output failures get one retry, because the model might produce a valid response on a second attempt with slightly different framing. Next, key concepts. 3 things to understand. First, input guardrail checks. Prompt injection is an attack where the user tries to override your system instructions by including text like, "Ignore all previous instructions," or "You are now a different assistant." Personally identifiable information, or PII, refers to data that can identify a specific person: credit card numbers, social security numbers, email addresses, phone numbers. Off-topic requests use your AI tool for purposes it was not designed for. Jailbreak attempts try to manipulate the model into bypassing its safety guidelines. Second, output guardrail checks. Format compliance means checking whether the response has the structure you expected. If you asked for JSON and got plain text, that is a format failure. Toxicity refers to harmful, offensive, or dangerous content in the response. Confidential data leakage means system prompt contents or internal instructions appearing in the response. Hallucination detection means checking whether claims in the response are supported by the source documents. Third, implementation tiers. Tier 1 is the free baseline. Anthropic's built-in safety filtering is always active at no extra cost. Tier 2 is simple custom validation, Pydantic output validators, and regex PII detection. These cover the most common failure modes and require very little code. Tier 3 is a full guardrails framework, like Guardrails AI or Nemo Guardrails, which provide pre-built validators, a hub of community validators, and a declarative configuration system. Start at Tier 2. Move to Tier 3 when your needs grow beyond what simple validators can handle. Next, project setup. Install FastAPI, Unicorn, Pydantic, Anthropic, and Python.env. For the full Guardrails AI framework, install Guardrails AI separately, and then install specific validators from the hub as needed. Separate your code into 4 files. Input.guards.py holds your input validation functions. Output.guards.py holds your output validation functions. Main.py wires them into the FastAPI endpoint. TestGuards.py tests all your guards in isolation. The most important advice on this slide is in the tip at the bottom. Always test your guardrail functions in isolation before connecting them to FastAPI. A guard that crashes inside an API request handler is much harder to debug than a guard that fails in a standalone test script. Next, inputguards.py. This file defines 3 guard functions and 1 dispatcher that runs all of them. The guard result data class is a simple container for the result of a guard check. It has a past field that is either true or false, and a reason field that explains why a check failed. A data class in Python is a class that is defined primarily to hold data. You get an init method and a string representation for free without writing them yourself. The injection checker uses a list of regular expression patterns. A regular expression, or regex, is a text pattern that describes a set of strings. The pattern R ignore all previous your, instructions, rules, guidelines, matches any text containing the word ignore, followed optionally by a qualifier word, followed by a target word. The research function returns a match object if the pattern is found anywhere in the string, or none if not found. The PII checker uses a dictionary of named patterns. Each value is a regex pattern for a specific type of personally identifiable information. Credit card numbers follow a 4-digit dash 4-digit dash pattern. Social security numbers have a 3 to 4-digit structure. The word boundary marker, written as \b, ensures patterns match whole words rather than substrings. The run input guards function runs all 3 checks in sequence. If any check fails, it returns immediately with that failure. If all pass, it returns a passed result. This is called fail-fast behavior. The system stops at the first problem rather than collecting all problems. Next, outputguards.py. This file validates the AI's response before it reaches the user. The expected response class is a Pydantic model that defines the expected structure of the AI's output. Pydantic is a Python library for data validation using type annotations. A field validator is a method decorated with the field validator decorator that runs additional validation logic on a specific field after Pydantic's built-in type checking. The check format function takes the raw response string, strips any markdown code fences. Those are the triple backtick blocks that language models sometimes add around JSON, then attempts to parse it as JSON and validate it against the expected response schema. If either parsing or validation fails, it returns a failed guard result with an explanation. The model_dump method on a Pydantic model returns a dictionary representation of the validated object. This is what you pass back as the response data when validation passes. The check toxicity function uses a simple keyword list approach. For production, you would replace this with a proper toxicity classifier, but for learning, keyword matching demonstrates the concept clearly. The run output guards dispatcher runs all 3 checks in order: toxicity first, then length, then format. It returns the first failure it finds, or a passed result with the validated data if all pass. Next, main.py. The FastAPI endpoint combines everything into a single guarded call. The safe fallback constant is a predefined response dictionary that the system returns when all else fails. It is defined once at the module level, so it is consistent everywhere. The request handler has 3 clear sections. First, the input guardrail. If run input guards returns passed equals false, the handler immediately raises an HTTP 400 exception with the reason. A 400 status code means bad request. The client sent something invalid. The LLM is never called. Second, the LLM call with a system prompt that instructs the model to respond in valid JSON with specific keys. Third, the output guardrail with retry logic. If run output guards returns a failure, the handler makes a second API call, passing the original response and asking the model to correct its format. This is the retry. If the retry also fails, the handler logs an error and returns the safe fallback. If either the first attempt or the retry passes, the validated data is returned. The logging calls throughout the handler use Python's standard logging library. Logger.warning records guardrail blocks. Logger.error records retry failures. These logs are how you discover attack patterns and improve your guards over time. Next, test guards.py. This file tests every guard function with both passing and failing inputs. The test input guards function verifies three things. A normal question passes all guards. A prompt injection attempt is blocked. A prompt containing a credit card number is blocked. An off-topic request is blocked. The test output guards function verifies three things. A valid JSON response with correct field values passes. A JSON response with an invalid confidence value fails. A plain text response that is not JSON fails the format check. Each test uses an assert statement. Assert in Python checks whether a condition is true and raises an assertion error if it is not. The optional message after the comma is shown in the error output, which helps identify which assertion failed. Running Python test_guards.py before every deploy takes a few seconds and catches regressions immediately. If you change a guard pattern and it starts blocking legitimate input, the test will tell you. This is the same principle as unit testing applied to AI safety validation. Next, Guardrails AI framework. This slide shows the Guardrails AI library, which provides a more structured and feature-rich approach to output validation. A guard object is created from a Pydantic model class, a prompt template, and a list of validators. The prompt template uses a placeholder variable. In the slide, it is written as a variable name in curly braces, which Guardrails fills in at runtime. Validators are objects that check specific properties of the output. Toxic language with onFail equals exception raises an exception if the output contains toxic content. Detect PII with onFail equals fix automatically removes detected PII from the response, rather than failing outright. The onFail parameter controls what happens when a validator fails. Exception stops execution. Fix attempts to correct the output. NOP passes through with a warning, and reask prompts the model to try again. The Guardrails Hub is a repository of pre-built validators that the community has contributed. You install them with the Guardrails Hub install command. There are validators for checking valid Python code, detecting gibberish text, ensuring factual grounding, and many more. The result object returned by the guard call has two useful fields. Validated output contains the cleaned and validated data, and raw LLM output contains the original unmodified response from the model. Next, common errors. If the output format check always fails, the LLM is adding markdown code fences around the JSON. Strip them before parsing. Replace the code fence markers with empty strings before calling JSON.loads. If Pydantic raises a validation error about the confidence value, the LLM returned a value outside your allowed set. Add explicit examples to your system prompt showing what valid values look like. If legitimate user prompts are being blocked by the injection guard, your regex patterns are too broad. Use word boundary markers and test against real user messages before deploying. If PII patterns are matching things they should not, test each pattern separately. Email and phone patterns are particularly prone to false positives. If a guard function crashes on unusual input like emoji or Unicode, wrap every guard function in a try-except block and return a failed guard result, rather than letting the exception propagate. If the output retry always fails and users always see the fallback message, your output schema is too strict or your system prompt is unclear. Simplify the JSON structure or add more examples. If the Guardrails module is not found, install it with pip install Guardrails AI and then install the specific validators you need from the hub. Next, takeaways, 5 things to remember. 2 checkpoints are always needed, input guards before the LLM and output guards after. They catch different categories of problems. Input failures block immediately and the LLM never sees the request. Output failures get 1 retry attempt, then a safe fallback. Start with Pydantic format validation and regex PII detection. These cover the most common failures with minimal code. Log every guardrail hit with the reason and a truncated version of the prompt. The patterns in your logs are how you discover what your guards are missing and how to improve them. Test every guard function in isolation before wiring to FastAPI. A passing test suite lets you iterate on guard logic confidently without breaking existing functionality. Next is the Workflow 10, Observability and Evaluations, where you learn how to monitor AI quality in production and catch problems before your users report them.